Okay, so purpose of today's lab is that we want to investigate the relationship between normal force and the force of friction, right? We already know that the formula for the force of friction says that mu, the coefficient of friction, times the normal force will give us the force of friction, right? So what we're testing is what effect will normal force have on the force of friction, right? In order to do that, we're going to use an apparatus like the one you see pictured there, right? So you'll have one of these little friction carts, okay, that we have red-green engineered to have. You guys even know who red-green is? God, what a generation gap. Okay, true Canadian. Google him sometime. Okay, duct tape is the handyman's secret weapon. That was his thing. Also, if the women don't find you handsome, they should at least find you handy. That was his other thing. Anyway, okay, so you're going to have this this sled, this friction sled, okay, and you're going to be pulling it along the floor. Don't do it on a desk because the desks are actually too slippery, okay, kind of like the roads this morning. So we are going to do this on the floor. Okay, and it's quite simple. You're just going to hook the string that's on the friction sled to the force meter. Okay, now the force meter will be attached to those Bluetooth transmitters, so you're going to need the Bluetooth thing attached to your phone and all that again. This time, however, you won't be using the position one. You'll actually be looking for the sensor that says force pull positive. Okay, if you have trouble with that, I'll show you when we get to that point. But that's what you're going to be measuring, is the pulling force that this force meter is going to read. So it's got 2 finger holes. Okay, you put your fingers in those and you just pull until it just starts to move. Okay, and then that's it. Right? All you have to do is just pull. Now, don't jerk it, okay? Because if you jerk it, you're not going to get good data. Just slowly increase the amount of pulling force until you see it move. Then you're done. Okay. What we're going to test here is different amounts of mass inside the sled. Right? Because if we increase the mass of the sled, we're increasing what force? Well, hopefully friction, but that would be indirectly. Directly, what force am I increasing? The more mass I put in here, the heavier this gets. What do we call that? Weight. Yeah. If I increase the weight, what other force increases on a level surface? Okay, well, hopefully friction, but what other force? The normal force, right? The heavier I make this object, the harder the floor has to push back. Okay, so what we're changing here is the normal force, right? By adding more mass to the cart, okay, or to the sled. So every time we add to the sled, okay, we increase the weight of the sled, the floor pushes back harder, and hopefully that's going to cause an increase in the force of friction. Everybody kind of follow the design of the lab there. All right, so I've kind of given you now 2 of the variables. I haven't outright said what they are, but I've pretty much given them to you. So, okay. Now, in terms of things we need to control in this lab, okay, obviously we want to do this on the floor, but what should we probably do to the floor? Yeah, just give it a little, like a little brush off or something like that. I'll bring in a broom if you want to just give the area you're going to use a little bit of a sweep, right? But one of the things you're going to want to keep in mind is once you pull the sled forward here, should you use that same section of floor again? No, because if you missed anything with the broom or whatever, you've cleaned it off with the sled. So I would say that between each trial, you should be picking up the sled, brushing off the bottom of it, and setting it down on a similar piece of floor right next to where you were. Okay. In that way, we're controlling something else that might be part of this formula and making sure that it stays the same. Okay. The other things we want to be aware of is that we want to pull this the same every single time. Okay. When you pull this, you want to make sure the force meter is on the floor. Okay? You don't want to be pulling upwards because we've done some questions involving friction. We know that if we pull slightly upwards, we decrease the amount of normal force, right? So we want to make sure we're pulling horizontally with the force meter. Okay, so just put the force meter on the floor and pull that way. That way, at least it's consistent every time you do it. All right, and we don't bring in any other vectors or forces or anything like that. Okay, you guys can think up a couple other controlled ones there. Right. In terms of our hypothesis, okay, in our hypothesis, we want to talk about the relationship between the force of static friction, because that's what we're measuring. Once it starts to move, we're done. We're only dealing with the friction of when it doesn't move, okay, and normal force. How can it be used to determine the coefficient of friction? Right. That's what we're trying to find here, is use the relationship, which should be linear, to find the coefficient of friction between these sleds and the floor. All right, so in the if part, okay, you should probably talk about the relationship between these two. Okay. Okay. The and part, as always, describes the experiment, and in the then part, you should tell me how you can find the coefficient of friction okay, using the graph we're going to build in this experiment. And the graph we're going to build in this experiment is going to be a graph of normal force versus friction. That's mu. Okay, the coefficient of friction is mu. All right, so that's what we're looking for, and we're going to have a normal force versus friction force graph. Okay, and remember, okay, we are manipulating normal force. Spoiler alert. Okay, so make sure you put it on the right axis of your graph. Okay, so the procedure, like we said, is going to be pulling this sled with different amounts of weight in it. Okay, we're going to do 6 different trials for this. Okay, the first trial will have the sled being completely empty. Right, so you just take all the masses out and run the sled. Incidentally, I wrote it up here, but the mass of the sled, okay, with no masses in it, is 0.254 kilograms. Okay, so your first trial, empty sled. Okay, you need to calculate the normal force, which, as we already said, is going to be equal to the force of gravity acting on the sled. Yeah, and I'm not even really worried about that, as it's a bit more just kind of evident already. Okay, so the first trial will be empty sled. Second trial, put 2 masses in. Okay, the first 2 masses in. So that's my arms aren't long enough anymore. This is going to happen to you when you get old too. 10, okay, and then 20. So you're going to put in 30 grams on the sled the first time, and then the next trial, or sorry, the second time, and then the next trial you'll put in the 30-gram mass as well, okay, and so on and so on. So you'll put in 40 after that, and then the 50, and I think this one's 100. Yeah, and then you put in the 100. All right, everybody follow me on that. Okay, so only the first trial involves adding, or sorry, second trial adds 2 masses. Right. The reason being, I've just found over the years that when you only add this little tiny mass, it doesn't make a big enough difference. Okay. All right, so that'll be the procedure. Then Google Sheet, or sorry, the SparkView stuff will spit out the information for you, put it in Google Sheets. Now, it's going to look a little bit weird because you're not going to directly graph that information. The data that the SparkView app is going to spit out for you is the force of static friction. All right, but it's going to look weird because each time you do one of these trials, okay, the graph will go kind of like this, like this, like this, and then it'll just drop. Okay, it drops at the point where you went from having static friction to kinetic, because now it started to move. So for each trial, the only value that you need to get is the maximum pulling force before it dropped. Okay, so you pull it really, really slow until it starts to move, then you're done. Record that maximum force. Then you will build a graph where you have friction here, normal force here, okay, and you'll plot them. So the normal force you can calculate from the weight of the sled, okay, friction is what you're going to get from the SparkView app, okay, draw the graph as it appears. Okay, so you only need to get one value from your data for each trial. Just look down the column until you see the biggest number, take that, okay, as long as it's within reason. Okay, if you see one that's like, it was getting bigger, and then it dropped, and then all of a sudden it got bigger again, that's probably just use the one that's kind of the most obvious part of the experiment. Okay. All right, so that kind of goes through the rest of this here. Okay, you're going to have your graph, okay, and you're going to have all that in your analysis. Okay, so for the analysis, okay, you're going to fill in the graph here. So you got your mass, calculate your normal force. This is the values you get from the data. Okay, include this graph. Okay, I'm going to want it in there. And all the analysis is this graph and an explanation of how you found the coefficient of friction. Right? That is all you have to do with this lab. How, using that graph, did you find the coefficient of friction between the sled and the floor? So there's got to be kind of an explanation there and why you think that was the way to do it. So like a short paragraph is all you're going to have here. Okay? Then your conclusion and evaluation, same as always. Questions on what we're doing? Okay, so all the friction sleds are on top of the Chromebook container there, and the transmitters and force meters are on the table. Okay, all right, if you run into trouble, let me know and I'll help you out. Okay, have at her, guys.